All right, you gotta go. Are you gonna go? All right, you gotta go. Are you gonna go? You gotta go. That's a good choice. Hello, 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 everybody. Let's move this closer away from my noisy computer. I know you guys can hear my computer in the background, but I don't think it's too bad, especially when I'm talking. Welcome to CS 202. I think it's our 18th day. That's crazy. Let's do a syllabus update. Not only for you, but for me. See what we got going on. See what we got coming up here. I think that'd be nice. While I'm taking my time here, does anyone have any questions that they would like to ask? Please let me know. See what we got here. All right, looks like we got some time. Yeah, looks like we got plenty of time. So today we're going to finish up our templates. And then next week we're going to start with recursion, which will be super fun. I do need to make an edit here. We'll touch on exception handling, but we will not really spend all that much time on it. We won't have an assignment around exception handling also, so that'll be nice. That also means that I'm going to need to make an assignment here. So let's take a look at that. Just real quick. Yeah, okay, I'll have to get started on that. But yeah, we're about to get into the fun stuff. So hopefully you've been following along up to this point. The thing is, we're coming up on the end of C++. And we're going to start touching on the computer science-y things. So if there's any, more time left in the semester for you guys to pay attention to this kind of boring, well, maybe you don't think it's boring. I certainly don't, but we are definitely just learning how to use a tool rather than anything cool like time complexity and recursive functions and stuff like that. So we are coming up on the end of using the tool, and we are moving more into how to computer science. So hang in there, and let's get through this stuff. And yeah, I want to just say real quickly about the assignment that this assignment that you're doing right now is kind of a nice wrap up to everything that we've been covering in the past few weeks. We got some dynamic memory allocation in there. We've got some inheritance going on in there. We've got with virtual functions. And we also have templates going on in there. So that assignment is really kind of a big sum up of everything that we've been doing. And if you're having problems with that stuff, including dynamic memory allocation still, I still see in some of the assignments some problems. So if you get a seg fault, please just send me a message so we can get it figured out. Because if you don't figure out the dynamic memory allocation on the first assignment, chances are you're not going to get it right on this assignment. So let's work these things out. The extra credit grades went out yesterday. I was a little bit lazy on that, so for those of you who didn't get the full credit, please just reach out to me. Talk to me on Discord if you truly would like to know where you lost points. I guess technically you didn't lose points, right? But where you missed out on some points, please talk to me so we can look at that stuff. I know some of you already have. And as for all of that, we're going to jump back into our templates today. So let's just kind of quickly review what we talked about last time. I cleaned up these notes a little bit. I am zoomed in on my, notepad because we're using Notepad. So we're going to see some of this kind of weird stuff going on here, but I'm not going to try to fix it. I think that it's okay as it is. You can just download this and copy these notes into, say, Microsoft Word and format them however you'd like. So recall what is a template? Well, it's a function or a class that's equipped to handle generic types. Or multiple types, any types, right? Int, string, we talked about that. Could be user-defined classes, any of that stuff. So one block of code for pretty much any type. Now, there's one thing I would like to say. This is a type of polymorphism. So if you remember from the notes a little bit ago, let me just kind of fill them back in. So we've got function overloading. That's the first thing that we started with. And this is compile time poly. We've got function overriding, which is also compile time poly. Now I'm going to ask for some class interaction here. So the next thing we talked about was virtual functions. Now, do you remember what kind of polymorphism, either compile time or runtime? Which one was that? And then if you had to take a guess at templates, either compile time or runtime, what do you think it is? Now, I did put these in the notes, so not that I expect you to have memorized them, but we have seen them before. Runtime for virtual functions, that is correct. And then we're talking about runtime for both. And I don't blame you for that. Runtime time. But templates are actually compile time as well. And so let me just explain that a little bit. So when the thing with virtual functions is that there's dynamic memory allocation. We're using pointers here. So if this helps you remember that, dynamic, that term dynamic that we're talking about, maybe I'll put it in like some square brackets here so it looks a little bit differently. If it helps you remember that, virtual functions are definitely runtime polymorphism, and that's because we're using pointers. And what do we use pointers for? We use pointers to allocate memory during the runtime. And so what we're doing is we're allocating memory for a derived class into a base class pointer during the runtime. And so during the runtime, it's up to C++ or, the code, the object code, to determine what kind of function are we calling. Are we referencing the player class? Are we referencing the tank class or the DPS class? Are we referencing the mage class? These kind of things. When it comes to anything, these are all kind of the same, I would say. These are all kind of the same. And let's kind of talk about this. This is one block of code per, right? One block of code per overload. There's also one block of code per override, except that this is a little stricter, right? Because it has to have the same amount of parameters, and it's also only used in inheritance. And then templates are actually they are kind of like function, well, they're kind of like these things we've talked about, but it's one block of code for like all types per set of types, we could say. And this would be per set of types. Or parameters, right? But the thing is, when we code this, we specify that this is an overload, or this is an override, or that this template is in the code when we compile it. And so during compilation, what G++ does is it will go through and look for these things. And if we happen to be sorting a list of, say, strings using a templated sort function, it will substitute in the string for whatever type it is. So it does all the substitutions before the runtime. Now, there is a fun little... Let me check my notes. I know I have this link somewhere. And I hope I included it. And if not, then I'll just go there. Because I really do like this diagram that I'll show you here. Jeez, my IP address is showing, guys. I don't have a VPN. That's not good. Let me just broadcast that to the world. Well, it doesn't happen to say about the templates, but that's what I'll say here. If you go to Geeks for Geeks and you just want to check out this stuff, this nice little diagram is here. So Red Rose asks a great question, and I was just thinking about that myself. Can we use templates with dynamic memory? And the truth for that is I would say yes. In the sense that I would appreciate that, so I'll have to look a little bit more into that, but I think, in a way, that it could be both. Because if we had allocated our own, type, right? So let's say we do a class, or even an int, so just during runtime, we dynamically allocate some type, and then we dereference it and send it to a template function. And the template function will for sure handle it. So in that case, I do... I'm on board with that. So let me come back to this just once I've done a little bit more research, but you've convinced me. But we do know what polymorphism means, right? And we do know what these three are. And like I said, you can go reference that this little website here. I guess I'll put it in the notes for the other three. But yeah, that absolutely does make sense to me. Just going off my notes from last semester. But anyway, so that was a good little review. We talked about what general or generic things are, in which general things can handle lots of cases. And things that are general tend to be simple. It's kind of a simple solution. And it's not like a big, ugly case statement. So if you recall, since the extra credit assignment is done, I guess I'll just pull it open to kind of explain this to you. So let me go ahead and pull up this. So here's our original game.cpp. Get a nice little zoom in here. So if you look at this piece of code here, in which I'm checking to see if it's a ranger attacking a ranger, or if it's a ranger attacking a warrior, ranger mage, mage ranger, major warrior, mage mage, or warrior ranger, warrior warrior, or warrior mage. So this is a big, disgusting case statement, and this is not very general. I mean, in the sense, it does handle all cases, but notice it's not very simple. And so the moment that we grab our virtual functions and implement them into this kind of thing, all of a sudden we can reduce that big case statement to this one line of code. It's a very general piece of code. It's very simple. And so that's what I'm talking about when we say things that are general. What do templates do? Well, we can declare types and functions. And when I say types, I mean kind of classes, to work with any type of parameter or member that we want, with a few caveats, I guess, right, with the operator overloading. And so when we're coding our templates for the functions, there's two options, right? For one, the template type must be in the parameters, meaning that the template type is being passed in to the function, which tells the function what type we're working with. But if the template type happens to not be in the parameters, then we have to specify it with, I guess they're not brackets, but they're, what would you call these guys? Arrows? Carrots? I mean, I think the caret is more like that. In the triangle brackets. Let me know if you have any preference for those in these things. The less than, greater than sign. But so we kind of demonstrated that, of course. And so then I gave you an example of that. So if the type happens to be within the parameters, we can just pass it in. So it would replace the int here. It will say, all right, we're working with ints, or we're working with a string. But if that template type is not in the parameters, then we're going to say, hey, let's make sure that this is an integer implementation of this function, and let's make sure that this is a string implementation of this function. For classes, it's easier, in which the template type must be a member variable or function, and the class will always be declared with the type specified in the less than, greater than sign. So example, we've used vectors before. And whenever we declare a vector, we need to say, what are we working with here, right? This is exactly like we did with our matrix code last class, right? We said, let's do a matrix of ints, a matrix of strings, or a matrix of doubles. And then we have some additional notes here. Let me separate these out just so we can read them a little better. Yeah, that's okay. So recall that the keywords type, name, and class are interchangeable. So I'll demonstrate that a little bit more today, just to refresh your minds. And then recall this. This is probably one of the most important sentences that I said last class. So for any operator O, that's an O, used in the template functions, if the template is used with a user-defined class A, class A must have an operator O overloaded. So let's kind of just remind ourselves what we did last class in those notes, and I'll point out what I'm talking about. So notice here in this template function that we did for less than, this would be the operator O, and if we happen to substitute class A for these types, operator O must be overloaded, otherwise the compiler is going to yell at us. Operator O, or the compiler will yell at us because this has not been overloaded for class A. And then I said, how do we initialize template type to a default value, right? Well, we call the default constructor. And so this could look like anything, depending on what we name our template type. So if the type name happens to be T, then we're going to call T. But if the template type happens to be type 1, and recall I said that type name and class are interchangeable, so I kind of did that there. If the template type happens to be type 1, then we're going to call type 1. Makes sense? So that's kind of how we did that with our matrices, right? So here we did a matrix of ints, a matrix of strings. Here's the string, there's the int, and there's the double. And so if I want to initialize those values to be something, here I am in the constructor here, right, in which we specify either a width or a height. And then I did the memory allocation. And then when I go to initialize all the values in that matrix, I just called the type 1 constructor. And the reason it's type 1 is because up here we specified the type name as type 1. So we talked about that. And then here are the syntax, right? So today, we're going to go over an example where we use multiple template types in our functions and in our classes. And then I think there is one more thing. Oh, and then we're also going to talk about declaring or writing the definitions for function bodies or member function bodies outside of the class using templates. So I think what we'll do first is we're going to do a small example using multiple template types. And then after that, I think we'll develop just another kind of dynamic array class. I think that'll be helpful to you for the assignment. So I don't think you guys will have any complaints about doing yet another dynamic array. But while we're doing that, I will define those functions outside of the class so we can get a good example, a good visual of what's going on there. So we're going to go ahead and get started with that. And I don't really need to add anything to the notes here, but I might add just an example. Notice when we're going to use multiple template types, we're going to put a comma, and then we're going to add some additional things that go on here. So, with all that said and done, let's do a restart here on old Bobby. And we'll zoom in here so we got Bobby on the screen. And then we'll go to my favorite directory, my test directory. Clean out whatever I was grading. And then we will grab my favorite stuff here. And we will make a new file. This is going to be... we'll start with mt.cpp, but I'll rename it as I always do. And then we'll have our int main. Turn 0. And so for this example, we're just going to do a pair class. And it's not P-E-A-R, but it is pair, in which we happen to have pairs for things. We can also do triples. I will say this, if you're coding alongside me or you're taking any kind of notes on tests, I like to ask you to make a template class similar to the one that we're doing today, except instead of maybe a pair, it might be a quad or it might be a triple. So just pay attention here. It's very simple kind of thing what I'm talking about here. So we're going to make a class. I'm going to call it a pair, just like that. And within our class, we're going to have our public and our private modifiers, our access modifiers. And then we're going to do a template with multiple types. And so we want this class to hold objects of two different types. And it could be two of the same type as well. And so in order to do that, if you recall, like I said, all we have to do is come here and grab this code that I typed for you in the notes. Just put it there. And I always like to number my types, because what if we have more? So for example, we'll do type name type 2. And so there you can see that we have a template for two different types. And it means that these do not have to be the same type. And so in our private modifier down here, I usually don't put it here. I know some of you like to put it there, but I prefer not to. We can have a type 1 member 1, and we can have a type 2 member 2. And let's go ahead and start with maybe an operator overload. That is also something that's in your assignment. I think that you have to do an operator overload for the bracket. I will also quickly say in the assignment, you do not have to do the rule of 3, which was bad design on my part, but you don't have to code main, so you won't even be using them anyway. But for any of those, for any of you who do notice that, don't get mad at me. And I'm glad that you noticed it, and always remember the rule of 3. So like I said, we're going to start with an operator overload for this. But before we do that, I think we should do our destructor, or constructor and destructor. Can anyone tell me how I should initialize member 1 and how I should initialize member 2? I would appreciate your help. If I want them to be some default value, please let me know. And in the meantime, I'm going to make my type 1 M1 and my type 2 M2 parameter constructor on this side. And in here, I can just put the M1 and the M2. And then the operator that I'm going to want to do here is the... I always get it mixed up. But it will be the insertion operator, I believe, is what we call it. So it is going to be an OStream and operator that, which will take a OStream and it will take a pair. And it can be a constant pair that's passed by reference. Does anyone have any ideas here? I just want to make these default values. I might seem kind of like a trivial question because I've talked about it a lot, but I just want to make sure that we're paying. Yeah, almost, right? But almost. But if the type 1 and the type 2 are different. And so if I put type and type here, it will either call the same one, or I don't even think that this type happens to be defined. So that's okay. We'll just come back to the notes. Where did I put it? Here it is. So here it is. How do we initialize the template type to be a default value? We call the default constructor for the types. So using these notes, I even kind of tell you, if I want to initialize type 1, what is it? And if I want to initialize type 2, then what is it? I'm going to make you guys tell me on this one. And I'll be sipping on my tea in the meantime. Exactly. Thank you. Awful, that's exactly right. So if I want to initialize type 1, I call the type 1 constructor. If I want to initialize type 2, I call it type 2 constructor. And look, they turn color. At least in my VS Code they do. So you know that we got it right. So I'll even put these in some comments. So default constructor for default values. And then we've got our parameter constructor here. And then we've got our friend overload down here. Insertion. Did I say insertion before? I think it is the insertion. And so now we'll just do the overload for this thing real quick, and then we'll do some tests. And I have another question to ask you guys. If I'm going to declare a pair, P1, how do you think I would declare it if I wanted this to be, say, a double and a string? This will be O stream out, and this will be pair P. Does that not work? Oh, yep. Yes. Here we've run into a problem. So look, notice that this is the compiler here is yelling at me. And the reason it's yelling at me is because this is a template type. This is a template type. And so we have to make this. Now this is a little confusing because this is a global operator overload. And so in order for us to do this, we have to make this a template as well. So please, please let me know if this confuses you guys at all. And I want you guys to know that these two templates are not associated with each other. Each time we do a template, it's its own thing. So I'm going to even change the name of these things to remind you that this template is not associated with this template. And so now if I want to pass in this pair, I need to specify what type this pair is. T1, T2. And so similarly down here, if I want this to be a double and a string, I have to say that. Except double is not capitalized. And so hopefully that makes sense, right? And it kind of just looks like this here. in which however many types there are, we're just going to specify them, and we're going to separate them with a comma. Now, because this is a global overload, I have to specify what type of pair this is. I have to specify what type it is. And I'm going to say, well, at the time of this is a template type, so I'm not sure what it is. So I'm just going to template it again. See, so Peter asks, we need the template on the overload because it could be either type 1 or type 2, right? Kind of, yeah. So don't get confused here. This pair contains both of these. So in this case, when we do a double and a string, this one will be a double, and this one will be a string. And so in fact, the pair is containing both of those types. The reason, and it's kind of hard to wrap our head around, the reason that we need this is because this operator, I guess I'll put it in some words, is not a member of the class. So this operator does not know about the templates. And so just because this operator has no, it's its own thing, right? This is not a member of the class. And so it's kind of looking from the outside at this pair object. He says, hey, what type is pair? So we could do this. We could say this is a double and a string. And then the operator overload will say, all right, I'm okay with that. I'm okay with that. But this is not general enough. This is very specific. Because then we would need to copy paste this, copy paste this, copy paste this for every type of combination of types that we wanted. We'd have to have one for int, one for int double, one for int float, one for int string, one for int character. Hopefully you get the point, right? And at this point, we're essentially doing function overloads, right? Would you agree with that? At this point, we're doing function overloads every time that we decide to copy paste and make a body for that. And so since we don't know what type that pair is, we're going to want to specify. Yeah, no problem. We're just going to want to make sure that this operator knows that it's working with the template. So we have to say, hey, you're a template as well. And within this template, you can have class T1, class T2. Right, these are interchangeable. I'm just pointing it out again because I keep doing it. And I'm going to put in here that this is T1, T2. This is the order. This is the order of types in this class. And we're going to do more examples with this. So if you are confused, I don't blame you because this is kind of whack. But we're going to keep coding. So things should be okay. Hopefully, eventually. You'll definitely have practice with the assignment. And so in this operator, I just kind of want to out something. And I would love to out maybe I don't know, maybe our bracket, maybe our pair can use brackets. And then we're going to do the pair, which is P, right? That's the object. That's P. And we're going to do the first member. And then we'll do a comma. And then we'll do the second member. Now, I'm going to ask you another question here. And at this point, I'm repeating myself. But are there any potential problems? Are there any types that won't work with this operator overload? And, you know, I've asked you so many times already at this point. Well, I'll let you see. I have some time to type out some stuff in main, and then I'll come back to it. So let's make this maybe a 3.4, and this can be loaf. And we'll make another pair. Let's say we do int. Yeah, that's a great answer. Thank you, Seabay. That's exactly what I want you to say. And so any of these future user-defined classes that take place of this member, right? So just as an example, if I make a struct student, just like I did last time, and I say, I don't know, int GPA, that's it. So that's the only thing I do. And then somewhere down here, I say pair student string P4 maybe. And then I do something like cout P4. Hold on one sec. I just kind of want to clear out all of my errors that I got going on here. What is this telling me? More than one operator matches these operands. Well, let me finish these. So maybe we can do a short in a character. I'm just kind of showing you the power of the template here. 947. I think that'll fit in a short. We can do L. What is this telling me? Oh, can I convert this as a short? I guess not. I guess we'll just do an int instead. I think why it's complaining is that this is... What did I mess up here? I'm totally missing something. What is it telling me? Oh. Okay, I was getting a little confused there myself. I don't know why it would underline this thing, because I had... Isn't IntelliSense great? That's how you know it's perfect. Is when you mess up this, it underlines this. That's amazing. So awesome. I had to read the error. So that could work. And then we could do even a float. All right, so there's nothing that says the types don't have to be the same. There's absolutely nothing that says that. And then I wonder why it's doing this. I wonder if it's even telling me that this is not okay. I wonder why it's telling me this. Did I template this? Yeah, I did. I wonder if I have to... Let me check my notes. I'm pretty sure I did something with this. I wonder... Let me try this. No, it doesn't like that. Well, let's try to compile it. I think that that's worth a shot. I think what it wants me to do is it wants me to tell it what it's working with. Though I should have done this nicely. Let's go ahead and see what Bobby says. Chances here I'm just making a silly mistake, which I always do. All right. What are you saying? So I wonder if I need to do this. Just copy it in here. Okay, I think that fixed it. And we'll talk about this. I'll definitely have to put this in our notes somewhere. All right. We did it, folks. We did it. All right. Let me come back to my chat here. Let me recoup with you guys. So, if this wasn't confusing enough, let's try to explain what happened here. I hope you guys can still see it if I zoom out a little bit. Literally, yes. So Red Rose asks, we have to make all of our global overloads as templates. And that is correct. So the issue here is I didn't have this and I didn't have this. And initially, IntelliSense is telling me that it's okay, because this is within the pair class, and it says, I know what a pair is. I know what it is. And you know what it's doing. Can you guys tell what types it's associating itself with? You can see there it says template class type 1 and class type 2. Do you see there? That's what the pair is associating itself with. But if you recall what I said, this template is not associated at all with this template. So I need to make sure that the compiler knows, or I guess even the runtime, that these templates are not associated with each other. And so if we're going to make this a friend, class, we need to make sure to disassociate this pair from these template types. Are you confused yet? Because I hope you are. And if you're not, then, well, I won't say anything. But so back to the original thing that I was saying, that CBay answered my question, is that the moment I put a student in here and I try to see out, it's going to come up into here, and it's going to try to do this part here. And this operator is not overloaded for student. So that's where we'll run into some problems. That's where we'll run into some problems. So I wonder if there's anything else that I want to do for this pair type. I think we could just leave it here. And we'll try to quickly go over maybe our dynamic array class. And for that one, I'm definitely going to speed through it, okay? Since we've done it before, I'm just going to kind of type away. And when I get to the templating part, we'll kind of slow down and take a look. So are there any questions about doing this, right? I guess I'll say real quick. If I want to add more, I'll just say type name, type 3, and the list just goes on. So just recall that. And I'm glad that we did this. So let me come up here and grab my favorite stuff. And once I save this, I just kind of want to put in the notes here. If we do not include, and I'll put something also in the notes after class. I kind of want to take some time to put the words together that's appropriate for whatever I'm trying to say here. But just recall that if we do not include this template, the pair parameter associates itself with the other template. So CBA, I would say that this follows the same name convention of variable names. So if I came down here and I said int Bob : B, it probably doesn't like that. If I did this, it probably doesn't like that. If I tried to put a number up front, it probably doesn't like that either. So anything that's in these, and then anything that's in these, as long as there is a letter in front of those. And I guess underscores will work as well. That'd be good to include in the notes. All right, so we're going to do dynamic array. I got about 20 minutes, so we're just going to kind of speed through this. And I'm going to put a hint here. This will be like the dynamic bucket. Okay? So be like the dynamic bucket in your assignment. Okay? So, try to get a good feel for what's going on here. So we're going to make a class, and it's going to be template type. In this case, it's going to have just one type. Call it T in this case. Just to show you, we can name it whatever we want. And in the private values, we're probably going to have an int size of our array, and we're also probably going to have a pointer. Sorry, folks. Sorry, folks. I always make mistakes. You know this. I have to include that, of course. But we're also probably going to have a pointer to our array, right? That makes sense. Hopefully it makes sense by now. We know what this is. This is either going to be an int, a string, a character, or a float, or a double. And the public, let's just quickly do our rule of 3 at super speed, including other stuff. So we'll do the dynamic array default constructor, which actually doesn't need to do anything other than say size is initialized to 0. The dynamic array, I say we're not going to do anything but this, and we'll make an insert function instead. But in this case, we're going to overload the copy constructor. So what we're going to want is a constant dynamic array passed by reference copy. And then I'm also going to want a destructor. And then I'm also going to want I'm doing the rule of 3 here. I'll put this in the notes. Just to remind you that we're still doing all the same stuff. And then we're going to do an operator overload. So we're going to have a void operator, assignment operator, right? Which is going to take in a constant dynamic array copy. We would also call it maybe the right-hand side. And that's the stuff we'll work on. And then on top of that, we'll do a member, some member functions. And I think the only ones that you really need to do, or the main one that you need to focus on for the assignment, would be a void insert. Now, this insert is going to take in one of these values, right? We're inserting to this array. And so it's going to take a t. It's just going to take a t. Does that make sense? So now I'm going to declare these outside of the class. And when we do that, we kind of have to do the same thing that we did here. Even though this is a global function, we're still going to have to do it with the members. So let's kind of just go full speed ahead here. The first thing I'll do is the dynamic array destructor. This one's very easy. We just have to delete the array. Notice it's yelling at me. And the reason it's yelling at me is because this needs to be a template type name t. T. So yeah, I definitely need to add this thing to the notes. We have to even include that in the namespace. So if there's a rule to be learned here, when in doubt, declare a template and fill in the values. Okay, that's what we did here. When in doubt, declare a template, fill in the values. When in doubt, declare a template and fill in the values. When in doubt, declare a template and fill in the value. But we have to do this for literally every single definition. And so in your assignment, you might opt to put all the definitions in here to make your life easier. I won't blame you. You are very welcome to just come in here and say, hey, I'm going to put my body here so I don't have to do all that crap down below that I just did. So now if I want to do the next one, I'll just copy this. Look at how easy this is now, though. I'll just copy it. I'll just copy it over. Let's do our operator next. Does that work? No, it doesn't, because I need to include the type. It should be void. Operator equal. What do I do here? All right. I guess it was yelling at me because I needed to give it a parameter. I guess that's fine. All right. So look, I included the same template, and I included this type within the brackets. Like I said, we're kind of disassociating it. I could say class C here and just put it as a C. And it will still work just exactly as you would imagine it to. So in the equals overload, we got to do one thing first. Step one, deallocate. Delete the array. Step two, allocate. We're going to say size is equal to the right-hand side dot size. We're going to then say array is equal to new. What is it? C. Are you confused yet? I changed the name to a C of the same size. And then step three is a deep copy. How do we do deep copy? Well, we just use a for loop. Some of you guys use enumerators. I haven't really covered those in that class, but if you use enumerators, you're so welcome to do that. I like my for loops still. I'm kind of old and stubborn, I guess. But one day I'll make the switch. So we'll do our deep copy here. And we got to say the array dereference that I is equal to the right-hand side array dereference that I. And that's it, right? That's our equals overload. Do you think I have to put a C here? I think I do. I think maybe we'd run into some problems here. But I guess we'll see. They would have to be of the same type anyway. So let's go ahead and stick with that. Let's do this for now. I want to see what the compiler says to me. I'm sure we'll run into some compiler errors below, and maybe this can help you guys see what happens when we forget this thing. All right, so now I'm going to ask for some class participation. How can I do the copy constructor? What's the easiest way I can do the copy constructor? What do you think? It's not a void. Rather, yes, thank you. I'm so proud of you guys. Never forget that. Never forget that. Never forget that. This should be okay. I don't know why it's... Yeah, I think it's mad. I guess we'll see. All right, so that's our rule of 3. And then let's do an insert. Insert will be pretty easy. Well, no, it won't, but I'll try to make it easy as possible. This is going to be a void value. It's going to be insert. And let's put in a comment here that this inserts to the back of the array. And then maybe I'll even put in a sort. I'll even put in a sort. Yeah, Red Rose, I see you got that there. That's the assignment. Well done. And so we're going to be inserting some cval to this. And so the first thing that we'll check to see is if... Here, can we implement this a different way? What do you say? Can we have an int size and an int max size? Maybe you guys will remember back in the day when we were talking about how inefficient our insert function was. How about we do maybe index and size? So where is the index located at, and where is the actual size of our array at? And then there's a few things that I'm going to do here. The first thing I'll do is I'm also going to want to copy that same index. And then in this case, we only need to go up to the index. We won't need to go up to the full size. That'll work. And so here's what we'll do. First, we'll say if index plus 1 equals our size. And so what does this mean? This means is... And I'll give you an example of that. So pretend that we're doing something like this with our array, where it's kind of empty. And what we'll do is we'll actually fill it in kind of one by one. So this will get maybe a 3, a 2, a 1, a 7. And so in this case, the index, I, will be, this is 0, 1, 2, 3. The index will be here. And the size of this array is, looks like 6. So if we take 3 plus 1, it's not equal to 6. We'll even say this is better, greater than or equal to. So we take 3 plus 1. It's not going to be greater than or equal to 6. That means we've got an empty space here, right? We've got an empty space to insert something. But if this happened to be full, the index would be located at 5. So we'll take index plus 1, which is equal to 6. And is that greater than or equal to 6? It is. So that means we have no space left in our array. It means that our array is empty. So then we'll kind of do this whole new allocation thing. So we'll say here, array, we'll put it inside the if statement. So if that array is full, then maybe let's say we're going to want to make a brand new array. And we're going to say is equal to new C. And then we're going to want to increase the size. So how about we do just a constant increase of plus 10. So every time we'll just tack on 10 empty array spots at the very end. And so that's kind of like step 1, allocate there. We don't have to delete yet. Step 2 here, this is an insert function. This is not a copy constructor. We got to do a deep copy. And we'll say that the new array is equal to the old array located at the index. It could also be the old size, either one. But actually, I just realized something. If we're keeping track of the index, then we're going to want to do a less than or equals there. In this case, if we do less than, size is always going to be greater than 1 to the index, at least when the array is full. So we'll just put that there instead. And then what we'll do is we'll say size plus equals 10. This is where we kind of add our space. And then lastly, we will say delete the old array, and then we'll say the array is equal to the new array. So Red Rose asks, instead of remaking arrays and deleting old ones, could we just make the last element of our full element be a pointer to a new array that has the new items, and then write code that detects when the index hits the pointer and reads in from the other array? So I really like how you're thinking there. I really like how... Does anyone know what that sounds like? Does anyone have any ideas about what that sounds like? And if you do, throw it out there. The reason that I kind of don't like it, well, there's an implementation. The way that would have to work is, say we had this array of ints. The last one would have to be an int pointer. And so then already we've got an array that doesn't have all of the same types in it. And so the fix for that is we could do int pointer, an array of int pointers. And then in this case, this could actually just point to like a 3, a 4, a 5, a 6, a 7. And then this one could then point to a whole new array. Down here. So you could implement it that way too. Does that make sense? But they would all have to be the same type. What do you think about that? It's not possible. I mean, I'm sure there's some hoops you could jump through, but if you had just ints in here, and then the last one was an int pointer, the compiler would be like, hey, this array doesn't contain all of the same type. But if you wanted to do this one, I would say inserting would be more efficient. I would say actually accessing the elements would not, because you would need to dereference the address. And then this kind of becomes a problem here too, because if you had the array, you would have to locate it at 1, 2, 3, 4, 5, 6, or 5, and then you'd have to bracket it again and start over at 0. You know what I mean? T. Peter here says linked list, and that's exactly what I meant. Yes, that's a linked list. And guess what? Guess what? I know it's kind of hard to see. Maybe I do this way. Yeah. We've got linked lists coming up here. We got linked lists coming up. So I would say Red Rose, you'll learn a better implementation of this in the coming week or two. The thing to recall about these is that is our array going to be inserting for the most of its lifetime, or is it going to be being read from most of its lifetime? And then depending on which of those things happen, we might choose to optimize our array to be better for inserts or to be better for reading things from it. You know what I mean? But yeah, you're already thinking ahead here, and I love it. This is kind of a happy medium, what we're doing here. So in our insert, I'm just going to kind of reiterate, get myself back on track. If our array is going to be full, then we'll add 10 to it. We'll copy all the old stuff into the new one. We'll then actually increase our size by 10. We'll delete our old array, and then we'll assign our new array equal to the new array. And then down here, we can say array at the index plus 1. Or if you guys would prefer plus plus, index is now equal to the value. So that's a quick little insert there. This code handles the resize here. This code handles the resize, and then all we have to do is kind of plop it on the end there. And so we're kind of running out of time here. So maybe I'll just do a quick little print. Well, let's do the main first. Make sure everything compiles, and then we'll kind of get started here. We didn't get a chance to go over a sort. But I think you guys can reference from assignment 1 and 2 your sorts, copy them into this assignment, and then you're going to have to make them templates. But I believe in you guys, and if not, I'm here for you as a resource. So what does this look like? This looks like a vector, right? But instead of using pushback, I'm using insert. Our destructor should deallocate all of that. So let's just kind of pull it in here, make sure it compiles. And then I think we're good to go for the day. Of course, I'll get no compiler errors. Wow. No seg faults either. All right, so I'll call it at that. You guys will just have to take my word for it that this worked. Let me make sure Valgrind worked as well. And if you guys are happy with that, because I am, you're free to go. If you guys got those questions, throw them out there now. Red Rose is full of the great questions today. So is Sibe. So is Peter. So any of you guys, you got any questions, let me know. Office hours are in 15 minutes. You've got the weekend to do that assignment, so send me the questions, you know. Reference this code. This code. Reference this code. This will help you. I'm here for you to help you, so please allow me to do that. I'm going to make some updates to these notes, and I'll upload them. I'm going to upload this code, and I'm going to upload this recording. So, yeah. Hope you guys have a great day. Have a great weekend. And I will see you guys on Monday.